Hello everyone. So today we are going to discuss about the magnetics design for safety. So how we design the magnetic components which comply the certain safety design standards. So let's start. So common safety standards which are getting followed in magnetics are IEC and UL. So IEC 6950-1. This is the safety standards for information and technology equipment. IEC 60601-1. This is the safety for medical equipment. And IEC 61010-1 is the safety of major control and laboratory equipment. And IEC 61558-1, it is a safety for power transformer and power supply. So the new safety standards IC 62 368-1 is audio, video and IT equipment. UL 1446 tells us about the electrical insulation systems which define the different temperature class, and mainly we follow the UL and IC standards for magnetics designing uh, for the components. So what are the common inputs which we need for designing the magnetic component to ensure that it meets these safety standards requirements? It's a material group according to the CTI. Second one is the insulation grade, then pollution degree, over voltage category, RMS working voltage, peak working voltage, and RMS main voltage. So under material group, tracking index, the voltage which caused the tracking after 50% drop of 0.1% ammonium chloride solutions have fallen on the material. The result of testing at 3 mm thickness are considered representative of the material performance in any thickness. The tracking is an electrical breakdown of the surface of an insulation material. A large voltage difference gradually creates a conductive leakage path across the surface of the material by forming a carbonized track. So that's why we categorize material tracking index under different categories. And here is the table according to the IEC and UL. So best material is the uh, material which has the tracking index as a 1, and comparative tracking index voltage is greater than equal to 600 volt. So under the different voltage requirements we can consider the different materials. So next requirements is about safety is the insulation grade. So what insulation grade is required for our parts between the different windings, and what kind of insulation is required between the primary and secondary, like between primary and core, secondary and core. So here we will briefly just go through that what are these insulation grades. So functional insulation, this is only necessary for the correct functioning of the equipment and does not provide any protective against electrical shock. The basic insulation, so this insulation applied to live parts to provide the basic protection against electric shock. The supplementary insulation, so this is independent insulation applied in addition to the basic insulation in order to provide the protection against electric shock in the event of failure of basic insulation. The double insulation, this comprises both basic insulation and supplementary insulation. A reinforced insulation, this is a single insulation systems applied to live parts which provide a degree of protection against electric shock equivalent to double insulation system, equivalent to double insulation. Then the pollution degree. So what are the different pollution degree? According to the IC 6950-1, three pollution degrees are defined. So pollution degree 1, pollution degree 2, pollution degree 3. Under pollution degree 1, it applies where there is no pollution or only dry non-conductive pollution. The pollution has no influence. Normally this is achieved by having the component and sub-assembly adequately enclosed by enveloping or hermetic sealing so as to exclude dust and moisture. The pollution degree 2 is applies where there is only non-conductive pollutions that might temporarily become conductive due to occasional condensation. It is generally appropriate for equipment covered by the scope of these standards. And pollution degree 3 apply where in local environments within the equipment is subject to conductive pollution or to dry non-conductive pollution that could become conductive due to expected condensation. So we have to define that where this component is going to work and what kind of pollution degree it will go. Next is the over voltage category. So over voltage category by IC 6950, it has been defined under the four different category, and the category 1, 2, 3, and 4th. So equipment and its point of connection to the AC main supply, and then what are the examples of equipment. So under category 1, equipment that will be connected to the special AC supply, in which measure has been taken to reduce the transient. So this is example for this is like IT equipment supplied by an external filter or a motor drive generator. Second is like pluggable or permanently connected equipment that will be supplied from the building wiring. So under this category, over voltage category, the household appliances, portable tools, home electronics, most of the IT equipment used in the building. Under third category, the equipment that will be an integral part of the building wiring. So like socket, outlet, fuse panel and switch panel, power monitoring equipment. And fourth category comes like equipment that will be connected to the point where the AC main supply enters the building. So this is the electricity metering, communication, information technology equipment for remote electricity metering. So these are the different over voltage category. So this also we need to keep in mind, and according to this, the component need to be designed and material need to be selected. So what is the working voltage according to the BDE, and this is the schematic which is shown that how the working voltage is considered. So the highest voltage that the insulation under the consideration is or can be subjected to the under normal operating condition. So this is the operating voltage V0, and this is the supply line, and this is how it enters to the equipment. So we need to consider about the what will be the working voltage. The next important things comes about the creepage and clearance requirements. So what is the creepage and what is the clearance? We will discuss it in details. So creepage and clearance distance is determined by the working voltage, the maximum system voltage between the primary and secondary, the bobbin material group, so by comparative tracking index CTI, and then insulation grade, like what kind of insulation is required, basic, supplementary or reinforced. And as it is shown here, the clearance is the air distance between the two conductive points through air, and creepage is the surfacial distance between the two conductive points. So this you can see here that from this point to this point is the clearance through air, direct distance, and through green path it is shown like this. This is called creepage. So example of safety standards according to IC 6951, like working voltage is 320 volt RMS, working voltage peak is 400 volt, main supply voltage is 240 volt RMS, material group is 3, over voltage category is 2, insulation grade is basic insulation. So from safety standards, dielectric voltage will be 1500 volt AC, creepage 3.2 mm and clearance 2 mm. So if we have this inputs, we can easily calculate that what will be our creepage distance, what will be the clearance distance, and through for calculation of this we need to refer these standards, and some of the manufacturer even provide some kind of calculators where we can input these parameters and then we can calculate the creepage and clearance requirement. So creepage and clearance, what should be the minimum creepage and clearance distance? According to the IC 6950, here is the table provided under the different material group, under the different working voltage requirement and different pollution degree. So we can follow this table and we can find out appropriate creepage and clearance distance. The minimum clearance for insulation in primary circuit and between primary and secondary circuit. So this is can be calculated according to this table. And here is the one of the examples which we have shown that how the safety calculators can be used to calculate the creepage and clearance distance requirements and dielectric voltage requirements for any components which follow certain safety standards according to their inputs like working voltage, pollution degree, insulation grades, and over voltage category, peak working voltage. RMS mains voltage. So this is one of the examples. This is the second examples. Then the next safety standards comes mostly about the wire, insulated wire. So the triple insulated wire, what are the good things about this triple insulated wire and what are the downsides? So the good things is that internal safety distance are easily met if we use the triple insulated wire. Then we can use the full winding width of the bobbins which is available. And the downsides is that this is not automable, hand strip and terminate operations per wire. Then material costs are higher than the magnet wire. Then price by length, not by weight. So these two things are the downsides, that the cost will be high for triple insulated wire, and price is by the length, not by the weight. Because most of the magnet wire we can buy in the market by the weight. Then triple insulated wire TEXE 130 degree C class UL. So this is a reduced diameter compared to TCA3 top one, which is 155 degree, and this can accommodate more turn, less cost. Then this is also approved by UL and BDE. For certain cases, maybe some extra test might be required, and this is also not automatable, so we cannot automatize. The next is the fully insulated wire, which is FIW 180 degree class C. So this is lower cost than price by weight, and then this is automatable. We can use the machines for AWG less than 30. And this downside is that only able to use for this design with only BDE approval. This is not recognized by UL. And then PFA, reinforced insulation system. So this is a higher temperature rating preferred for assembly package. So how to achieve the creepage and clearance distance? Here is one of the examples it is on. Use the extended rail win and margin tape to increase the distance from secondary pin to primary winding. Here we can see that how this rail has been increased in the bobbin to increase the creepage distance, and here also you can see that from this conductive part to the winding of the secondary. And here we can see that the triple insulated wire has been used for secondary to insulate the winding. So if we use the triple insulated wire, the safety requirements are easily met. Thank you, and we will see the next topic in the new video. Till then, thank you very much.